Today, the world is in a biodiversity crisis, with over 1 million species now facing extinction, yet not a single global target has been met. Why? Because our tools are outdated. Like Martian, the most widely used planning tool. It was designed to minimize costs, but it is static. That means it cannot adapt to climate change. It cannot respond to human disturbance or use real-time data. As the world changing faster than ever, our tool remain frozen in time, and that's why we are losing nature faster than we can save it.
That's why our team, BIOUniversity, created BioDiff AI, an AI framework with 4 core models that dynamically prioritize conservation areas. Our system integrates reinforced learning, neural networks, convolutional neural networks, and natural language processing. Together, these models continuously learn how biodiversity evolves under climate change and human pressure, and adapt strategies to save the maximum number of species with limited resources.
So let's talk about how it works. We integrate biodiversity data, such as species presence, abundance, and phylogenetic diversity, along with environmental data, including climate patterns and human disturbance. We also add remote sensing satellite imagery. Let's talk about process. How we process our data. Before data enters our model, BioDiff AI applies AI-driven data cleaning techniques. At first, removing duplicates, and then creating inconsistencies. And after that, we normalize format of the data. And the last, we detect other outliers. This ensures that the system can handle noisy citizen science input and also large heterogeneous datasets. Then our 4 AI models operate together. First, we use NLP to standardize survey and citizen science data. And next, we use CNN, a convolutional neural network, to analyze satellite image to detect habitat loss and deforestation. And then RL, or reinforcement learning, come to balance between exploration and exploitation to decide when and where to protect. And a neural network prioritization engine with ReLU rectified linear unit and softmax process all biodiversity feature to select the most cost-effective conservation units.
The output is powerful. Adaptive conservation map that highlight appropriate area. Policy recommendation show it trade-off between cost and biodiversity value, and performance metrics such as extinction reduction, number of species saved, and cost effectiveness. We also deliver this output to a simple BioDiff AI web app where users can view interactive map and dashboard. And policymakers or citizen scientists can easily access results online. The web app makes BioDiff AI usable by government, NGO, and community without installing any software. This makes BioDiff AI a multi-AI ecosystem that clean, learn, adaptive, and scale globally.
In ecosystem simulation, integrating species data, climate change, and human disturbance, BioDiff AI reduced species extinction by 26% compared with random protection policy. Compared to Mason, the most widely used tool, BioDiff AI was up to 18.5 more effective in reducing species loss. In real-world validation, on 1,517 endemic tree species in the United States, these results prove that BioDiff AI is more accurate, adaptive, and impactful than existing conservation planning methods. After all, with BioDiff AI, we are not only protecting endangered species, we are safeguarding ecosystem, forests, and coral reefs that humanity depends on. Our vision at BioUniversity is to support policymakers and NGOs with AI-powered conservation planning, enable citizen science participation to make biodiversity monitoring scalable, and most importantly, make BioDiff AI accessible. This is not just about saving data. With BioDiff AI, you save life itself. BioUniversity speaks on behalf of all animals, giving them a voice they cannot raise themselves.